This topic is going to be covering sets and Venn diagrams, and this first video is on sets. A set is a collection of numbers or objects. Each number or object is called an element or number of the set. A capital letter we often use to represent a set. So for example here I've got, if V is a set of all vowels, then we would use a capital V to equal, and then the set itself would just be A, E, I, O, U. A finite set is a set with only a certain amount of elements. For example, like the set before, a set of vowels, there are only 5 vowels, so it's a finite set because it's a set number. An infinite set is a set which doesn't end. For example, the set of even numbers, because we can keep on going with even numbers all the way up to infinity, therefore it doesn't have an ending point. And lastly, we have set A is a subset of set B if every element of A is also an element of B. Example of that would be if we have our universal set as 1, 2, 3, 4, 5. And let me just write this down so you can see what I'm talking about. So if we have a set that is, our universal set is 1, 2, 3, 4, and 5. And then set A is 3 and 4. To know if it's a subset, we're just looking at is all of A in our universal set. So 3 and 4, they are in the universal set of 1, 2, 3, 4, 5. Therefore, we can say that A is a subset, we'll get to the symbols in a minute, of B, because all of A is within B, and that's what subsets are. Here are all our symbols relating to sets. Quite a few there, I'm not going to talk through them. Make sure you have them written down because they will come up fairly often in notation, in questions, in the things that we go on to talk about. You'll see subset here, I'm just going to put a star next to it, which is just what I talked about before, and in the notation I'm just underlining there. But all of this we'll talk about in different questions throughout this topic. Now I'm just going to go on to a complement of a set. If I just quickly go back to the symbols, the complement is the top one here on the second column. Just going to put some stars next to it. That is what we are going on to now. To start with, if we are given a problem involving sets, the universal set, which is the capital U, it was also in our list of notation just before, is the set of all elements under consideration. Now, the definition of a complement of a set is the complement of A, which we denote with A dash. So I'm just going to put a circle here. That is a dash next to that, not A1. Sometimes gets miscommunicated there. Is A dash. Is a set of all elements of the universal set which are not in A. So kind of that we have the set of A, the complement is everything not in A. We have an example here. Suppose our universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. And our set A equals 2, 5, 6, 8. Determine the complement of A, A dash. So to determine the complement, we look at what we have in A, 2, 5, 6, 8. And the complement of that is everything not in A. So therefore A dash would equal everything in the universal set that is not A, which would be 1, 3, 4, 7, and 9. When you put the complement and the original set together, so they're A and the complement of A, those two together should equal the universal set. And in this case, you can see all the numbers are covered within those two sets. But main thing to remember, complement, the complement of A is everything not in A. Next, we're going to go into the intersection and union. The intersection of two sets A and B is a set of elements that are in both set A and set B. Now you see the notation we have here. We have this symbol in the middle. Go back to our notation from earlier. That symbol means the intersection. So this notation is A intersection B. We can then have two sets that are disjoint or mutually exclusive. They mean the same thing. Both words you can hear and will get used. Mutually exclusive is probably used more than disjoint. But if they, and what this means, they have no elements in common. Our notation, we've got A intersection B there, equals, and then this symbol, circling now, is the null set, or an empty set. So it means there's nothing in it. Next, the union of two sets, A and B, is a set of elements that are in either set A or set B. And you can also include that to almost say or both. Some people forget that you've also got to look at what's in both as well. Now our symbol here is a U to represent the union between them. So this notation means here means A union B. And when we're looking at the union, we're looking at, is it in set A or set B, but also could be in both. Quick example, suppose our universal set equals positive integers less than or equal to 12. And if you are unsure what an integer is, it is a whole number. A is equals to primes less than or equal to 12, and B are factors of 12. First of all, we're going to list the elements of A and B. So A is primes less than or equal to 12. So here we just need to know what our prime numbers are. And less than or equal to 12, we will have 2, 3, 5, 7, and 11. Big note here, a lot of people get confused. The number 1 is not a prime number. It is known as a special number. It is not prime. A lot of people include number 1 when they shouldn't with prime numbers. Now B, the set B, is factors of 12. So all the numbers that are factors of 12 will be 1, 2, 3, 4, 6, and 12. With all those numbers, you can use them somewhere with a multiplication of another one to get the answer of 12, so they are all the factors. In part B, we have list the elements in certain different situations. So part 1, we have list the elements in the complement of A, or A dash. Remembering the complement is all the numbers not in the set. So complement of A, all the numbers not in A. In A, we have 2, 3, 5, 7, 11. And all the numbers that are not in that but are in the universal set of positive integers less than or equal to 12 would be 1, 4, 6, 8, 9, 10, and 12. Number 2, we're wanting to know all the elements in A intersection B, or A and B for short. We've got A and B up above there, so we just look at the numbers that are common between both, and we can see that is 2 and 3. That will be our intersection, and then for part 3, we want A union B, which is A or B. So we're going to go through our whole universal set from 1 to 12 and have a look, is that number in A or B? And we'll find that number 1 is in B, and number 2 is in both, 3 is in both, 4 in B, 5 is in A, number 6 is in B, 7 is in A. Now the number 8 is in neither, so it can't be in the union. 9 and 10 also the same, they're not in either set A or B, so we're not going to write them down. But we do also have 11 and 12 in A and B respectively. Now part C that we're going on to is we're going to be finding how many are in certain situations. So when we have this little n at the front, so you'll see here for part 1, find the n open bracket A intersection B. So that is asking us how many are in the intersection of A and B. And all we need to do there is look at our A and B intersection, which is part 2 from above. I'm just going to quickly underline that. How many are in that set? And there is only the numbers 2 and 3, which means there are 2 elements in the set of A intersection B. Now in part 2, we want how many, the number in A or B, A union B. So how many do we have in the union? Which is part 3 from above. How many numbers do we have there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 in the union of A and B. Now part 3, we want the how many are in the complement. So for me with this one, I would actually write out what the complement of B is. So in B above we've got 1, 2, 3, 4, 6, 12, which are the factors of 12. Therefore the complement would be 5, 7, 8, 9, 10, and 11. And then we just want to know how many numbers are in the complement, and we have 6 numbers there. Another way we could look at it is we have 12 numbers in our original set. There are 6 numbers in B, and 12 minus 6 leaves 6 numbers. So the B and the complement of B must always add up to the original set. Therefore, because we have 6 in B, there must also be 6 in the complement of B. Different ways you can do it, you just do whichever works for you. Now that is the end of the first video on sets. The next video will go on to special number sets.